Welcome back, geometry students, to another edition of Your Notes. Today's notes are titled 9-3, Similar Right Triangles. Before we get started real quick, I do want to flip back to 9-1 and give you guys a chance, if you did not get these notes copied down for some reason, you can pause this video and get them copied down. Inside are the notes. So get those down for 9-1 Pythagorean theorem. Today's 9-3, similar right triangles, and hopefully in our exploration in class you guys got a good chance to look at what this figure is, what it looks like. On the outside of this figure, or outside of our notes here, I'm going to put a diagram or a picture of what it looks like. So we have one right triangle. A right triangle has a right angle, and then the altitude is drawn in that right triangle. The altitude is the height. It goes from the vertex perpendicular to the opposite side, just like that. Okay, and I'm going to label this triangle with a couple things, X, Y, and Z. And over here I've got two other sides, so I'm going to label it W and T, just for instance. Okay, when we solve similar right triangles, the easiest way to do it is to make a table. So on the outside here I'm going to make a table and just label it with the pieces that I have. On the inside of our notes I'm going to do a couple examples for you. Okay? The things that we compare, what I see whenever I have this original right triangle and draw the altitude in, I have those three similar right triangles. I know similar triangles, or similar figures for that matter, have corresponding angles congruent and corresponding sides proportional. So the way I'm going to set up the proportional sides is to make a table. My table involves the three triangles and the sides of those triangles. All right? And the identification of the triangles is like this. The whole entire thing is the large triangle. I've got a small triangle on that side there, and then a medium triangle. And like I said, the whole entire thing is the large. I can put the large on there. Large is the whole entire triangle there. Okay? Now, so my triangles, I'm going to label them small, medium, and large. I'll use SML. And my sides will be small, medium, and large as well. Every triangle, every right triangle in this diagram has a small, medium, and large side. Okay? Now all I have to do in this outside here is set it up. So on my small triangle, my small side is Y, my medium side is X, and my large side is Z. On my medium triangle over here, my small side is X, my medium side is T, and my large side is W. On my large triangle, the whole entire thing, my small side is Z, my medium side is W, and my large side is not just one letter, it's actually two letters put together, the Y plus T. Y plus T. Okay? Please pause the video and maybe even rewind it and see how I did that again. It's very important you understand just how we get those sides of the figures as we go through. On the inside, I'm going to use some numbers and actually solve for sides in a similar right figure. All right, so when you open that up, like I said in class, it might be easier if you open up a couple pages so that it's a harder surface to write on. Example number 1. Example number 1, we have a right triangle. On that right triangle, the altitude is drawn. This one's facing a little bit different direction, but there it is. I've got 11 for the side there, 25, and then that altitude is going to be X. I do not know that. Okay? It helps for me to label this my small triangle, medium triangle, and the whole one's a large. All right? And when I set up that table of my triangles and my sides, I've got a small, medium, and large triangle, small, medium, and large side. When I do it with just the pieces that I have, I'm not worried about the pieces I don't have. Just the pieces I have, look what happens. On my small triangle, my small side is 11. On my small triangle still, my medium side is X. On my medium triangle, my small side is X, and my medium side is 25. Now, check that out. Proportional sides, so when I have a small, and a medium, in two different triangles, I can set up a proportion and then solve for X. So let's do that over here. The table sets the proportion up for us. So 11 over X is going to be equal to X over 25. To solve for x, all I got to do is solve my proportion, and then involves cross multiply. So when I cross multiply, x times x is x squared. 11 times 25 is 275. And then once I have that, I can take the square root of both sides to get just x by itself. So x is the square root of 275 because the square root of x squared is the inverse. They cancel each other out. We just get x. Now I want to get this in simplest radical form. I know my factors of 275 once we find it out. We've got 25 and 11. And 25 factors down to 5 and 5. So therefore, pair of 5s, square root of 275 is equal to 5 square root 11. So that side x is 5 squared 11. Let's do one more example. Example 2. All right, draw another triangle. Hopefully, since I'm doing this with you guys, you can stay ahead, or you can stay up with me. You don't have to pause the video. It's my goal, at least. I've got a right triangle there, and then the altitude's always drawn in. That makes a right angle there. Again, 3 similar right triangles are created in this diagram. 36 is my side there. I've got 60, and then the whole entire large hypotenuse is labeled x. That's the one I want to find this time. Okay? Set up our table. Every single time when we set this table up, it really sets our proportion up for us, makes it really simple for us to solve these similar right triangles. And the triangles, we've got small, medium, large, sides, small, medium, large. Okay? Take a look at my small triangle here, my medium triangle there, so I can see it. On my small triangle, my small side is 36. And I'm doing this pretty quick, and you guys might need to look at it a little bit to identify the small sides, the medium sides, and the large sides. The large side is always the hypotenuse, so we know that. But I've seen these several times, so hopefully you guys get practice with that as well. On the small triangle, my large side, my hypotenuse, is 60. Okay. Do I have anything on my medium triangle? No, I don't. So let's look at my large triangle. My large triangle is the whole entire thing. I've got my small side is 60. And my hypotenuse, my large side, is x. Okay? Again, with that, it sets up the proportion. I've got, in my small triangle, 2 sides, my small and large. In my large triangle, 2 smalls, 2 sides, my small and my large. So it sets up the proportion for me. 36 over 60 equals 60 over x. 36 over 60 equals 60 over x. Okay? Solve for x by just cross multiply. 36 times x is 36x. 60 times 60 is 3,600. If I divide by 36, x is just 100. And I'm just solving for x. There was no squaring going on, so I'm done. Now, those are 2 examples. One note, and I'm going to put this kind of a star in the bottom here. The Pythagorean theorem may be needed to complete the table. To complete the table. Okay? Before we set up our proportion, or even after we set up the proportion, I can go back in here and check this out. Now that I have x, my hypotenuse of my large triangle there, I can use the Pythagorean theorem to solve for this side. I've got 100 here, I've got 60 here. I could use the Pythagorean theorem in my small triangle to find the third side there. And then I would have this side of the triangle there and this side there. So I've got 2 sides of my medium triangle. I can use the Pythagorean theorem again to find the third side there. That would be after. But before, like I said, sometimes we need to do the Pythagorean theorem to find one of these sides. I will give you an example of that in class. Hope you guys like these notes like this. Have a great rest of your day.